Hey everybody, in this video we're going to be practicing finding the equations of tangent lines. If you want to follow along, links to the companion worksheet are in the description below. So let's get started. So with number 1, we want to find the equation of the line tangent to y equals 2x squared minus x at the value x equals 1. So in order to find the equation of a tangent line, we need two things. We need a point and we need a slope. So to first find the point, we're going to substitute 1 in for x into the function f of x. So when we do that, we get a value of 2 minus 1, we get 1. So we know that this tangent line passes through the point 1, 1. But now we also need the slope, and that's where the derivative comes in. So down here, I'll find the derivative, f prime of x is going to equal 4x minus 1. And so now we want to find what is the slope at x equals 1. So f prime of 1 equals 4 times 1 minus 1, and that equals 3. So that gives us the slope. So now we have the information that we need to find the equation of the tangent line. Now some books will ask you to put this in slope-intercept form, and some books will have you put it in point-slope form. I'm going to show you both. Point-slope form is easier when you have the information in this form. Point-slope form looks like this. Y minus y1 equals m times x minus x1. y1 is the y value that the line goes through, m is the slope, and x1 is the x value that it goes through. So that means 1 is the y value that we found up here. The slope is 3 times x minus, and 1 is the x value that we're working with. So this is what it would be in point-slope form, and you can actually stop here if that's acceptable for you. But I'll put this in slope-intercept form also. So I'll multiply in the 3, so y minus 1 equals 3x minus 3, and then we'll add the 1. So y equals 3x minus 2. So same equation, but now it's in slope-intercept form. All right, for the next one, same idea. Here we want to find the point and the slope at x equals negative 4. So we substitute negative 4 in for x. So negative 3 over negative 4 squared minus 25. So we have negative 3 over 16 minus 25. So that's negative 3 over negative 9. So we get positive 1/3 is the y value. Now to find the derivative, this one's going to require a bit of, well, chain rule? Nah, I think we'll just use quotient rule for this one. So f prime equals prime of x equals low, so that's x squared minus 25, d high, which is 0, minus high, that's 3, d low, which is 2x, all over low, low, and that's x squared minus 25, and that quantity is squared. And we can simplify that a little bit. So we have negative 6x all over x squared minus 25, and that quantity is also squared. Now we want to find what is the slope when x is negative 4. But wait a minute, one little thing to note. This negative is like a coefficient. And so actually we should have a negative here and a negative here, which would cancel that out and make it positive. So I'll do that real quick. F prime of x equals positive 6x over x squared minus 25 squared. So now we'll substitute in negative 4 into f prime. So 6 times negative 4 all over negative 4 squared minus 25, and that quantity is being squared. So on the top, we have negative 24. On the bottom, we have 16 minus 25 squared. So that's negative 24 over negative 9, squared. So we get a slope of negative 24 over 81. And we could simplify that. There's at least 1 3. So we get negative 8 over 27. And that is the slope we're looking for. So now, to find the equation of the tangent line, we take the point and we take the slope, and we put it in this form that we used up above. So we have y minus 1/3 equals the slope, negative 8 over 27, times x minus negative 4. And we can deal with the minus and negative. So we have minus 1/3 equals negative 8 over 27, x plus 4. So to write this in slope-intercept form, we'll multiply in the negative 8 over 27. So y minus 1/3 equals negative 8 over 27, x minus 32 over 27. And then we'll add the 1/3. And when we add 1/3, instead of adding it as 1 over 3, we can add it as 9 over 27, which is the same thing. So we have negative 8 over 27x. And then when we add 9 to that, that should be minus 23 over 27. And that's our y-intercept, negative 23 over 27. All right. On to the third one. Here we have this equation, this function ln of negative x. And we want to find first the y value at negative 2. So we plug in negative 2. So we have ln of negative 2. And so we have ln of 2. Now I'm going to leave it in this exact form and not find the decimal, because doing it by hand with decimals makes it a little more difficult for me. So now we want to find the derivative. And here we have a little bit of chain rule. Not bad. So the outside function is ln. So we take the derivative of ln, which is 1 over. But then we also multiply by the derivative of the inside. And the derivative is negative x, so negative 1. Now thankfully the negatives will cancel, so we have 1 over x. So we want to find the slope, f prime at negative 2. So we have 1 over negative 2, so that's just negative 1/2. So now our value for our equation is going to be y minus ln of 2, just leave it in that form, equals negative 1/2 is our slope, quantity x minus negative 2. We're subtracting a negative 2, so y minus ln of 2 equals negative 1/2 x plus 2. And so there we go, that's in point slope form, and now I'll write it in slope intercept form. So I'll multiply in the negative 1/2. So we have negative 1/2 x minus 1, and then I'll add the ln of 2. So negative 1/2 x minus 1 plus ln of 2. And we just leave it in that form. So for the fourth one, this one's a little different, because here we want to find the equations of these tangent lines. Now, we don't know where it's tangent. That's what makes this problem so much more difficult than the first three. So how do we set this up? Well, we know that both of these points pass through this slope, this point 1, negative 3. And so what I can do is I can call this point t, comma, t squared. And so if I set up the slope between these 2 points, it's going to be the change in y values, so that's t squared minus negative 3 all over the change in x, t minus 1. But this is a tangent line. And so because it's a tangent line, we know that the derivative is the slope of the tangent line. So if y equals x squared, then that means dy dx has to equal 2x based on our power rule. So that means this is the slope by finding it between these 2 points. But because it's a derivative, we also know that whatever this x-coordinate is, the slope should be twice that. That's what the rule says. So we'll set this equal to 2t. Now, what we have here is we have one equation with 2 different values. And because it's going to be a quadratic. So what I'll do is, to get this to be solved, I'm going to multiply both sides by t minus 1. What that does is that gets everything out of the denominator. So we have t squared minus 3 equals 2t squared minus 2t. All right, like all good quadratics, we'll subtract everything to one side. So minus t squared on both sides, and then add 3. So 0 equals t squared minus 2t plus 3. Oops, forgot one little thing. Because of this plus minus, this should actually be a plus 3, and so we're actually subtracting 3 from both sides. All right. Now, because of that, we can solve this for t. 0 equals t minus 3 and t plus 1. So what we get is we get 2 values, t equals 3 and t equals -1. Now that actually makes sense, because what that tells us is we have 2 different points where this works. Right here, t equals 3, and over here, t equals -1. And so this coordinate should be 3, 9, and this coordinate down here should be -1, 1. And over here, the slope is going to be twice the x value, so the slope is 6. And over here, the slope is twice the x value, so the slope is -2. So we have 2 different tangent lines, so we'll write both of those. First, we'll write this one, so y minus, and it's passing through the y value of 1, equals, the slope is twice the x value, so -2, x minus -1. So y minus 1 equals -2, x plus 1 in point slope form. We'll multiply in the -2, so -2x minus 2, and add the 1. So y equals -2x minus 1. That is our equation for this tangent line up here. Now we'll do the same thing for this tangent line up here. So the y value of that point is 9. So y minus 9 equals, the slope is 6, twice the x value, times x minus 3. And that's point slope form. No more need simplifying there. But to put it in slope-intercept form, we'll multiply in 6. So y minus 9 equals 6x minus 18. And then we add 9. And so we get y equals 6x minus 9. And that's the equations of these 2 tangent lines. Thanks so much for watching. If you liked the video, please give it a thumbs up. For more videos like this, click the subscribe button. If you're a teacher, please share this with your students. If you're a student and you enjoyed this, please share this with your classmates. If you have suggestions or problems that you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the only way to understand something is to do it.